Okay, guys, we are going to do Punnett Square Practice Part 1. So, the first thing we're going to do is review your vocabulary. So, Punnett squares, the purpose of them is to help us determine the traits that are possible in the offspring of two parents. Dominant genes, dominant alleles, is represented by a capital letter. Recessive are represented by a lowercase letter. And again, those variables can be any letter in the alphabet. Homozygous means same, so either you're going to have two capital letters or two lowercase letters. Heterozygous, you're going to have a capital and a lowercase. Genotype, that is going to be a two-letter combination. Phenotype is going to be a characteristic, something you can see. It can be a color, it can be height, etc. So we're going to do, the first one's already done for you, but I'm going to kind of put some details and we're going to walk through these examples. So remember, anytime you're doing a cross, that just means that you're doing kind of like a multiplication of those two individuals. So the first one is heterozygous. So let's do some notes. Hetero means different. So this would be big little. Anytime you see the word and, put a cross on it. It tells you you are split up as two individuals. This one came first, so I'm going to put it on top. However, we have talked about it doesn't matter which side you put it on, it's just a different configuration if you go back and watch the previous video. The second individual is hetero. So again, hetero means different. So that means big little, and this one would go on the side. A lot of times these type of scenario problems, it will give you a key or let you know what letter to use for your genotypes, those two-letter combinations. This one is using the letter B. So here, capital B means blue eyes, so that's the dominant trait. Lowercase b is brown eyes, so that would be the recessive trait. So those characteristics, those are going to be our phenotypes. So that's how we get that information. So I'm just going to make some brief notes here. I'm going to write DOM for dominant, REC for recessive. So you know that that's dominant trait, a capital letter, the recessive trait, brown. So we cross those two individuals. So if it's hetero, that'd be big little, big little. And sure enough, that's what we have on our Punnett square. Remember, we match these up as we go. So here you match big, 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 little. This could be little, big, but remember, we usually write the dominant allele out front. Then we match the ending, little, little. So looking at genotypes, we look at all the different possibilities. You always just list them. So you would do big, 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 little, little, little. So looking at our Punnett square to figure out how we get these percentages, count the squares and you do your fraction. So for big, big, it's 1 out of 4 squares. That'd be 1/4, which is 25%. Big, little, that's 2 out of the 4 squares. So that would be 50%. And then last, you have little, little, which is 1 out of the 4 squares. So you have 25%. And a way you can check your work, because on the rest of these, you're going to have to do it by yourself, your genotype should equal 100% to represent the whole. And sure enough, 25 plus 50 plus 25 is 100%. So we're good there. So when looking at our phenotypes, we're looking at the dominant and recessive. Well, the only way you can get brown eyes is if it's totally recessive. Both the mom and dad had to give a recessive allele. So, in order to have brown eyes, we're coloring the BB, little b, which would be this one right here. The dominant trait was blue. So if it has at least one of those alleles, it is dominant. So this has two of them, so it's going to be blue. This one has one, so this is blue. And this one has one, so it's blue. So it has to have at least one of those to equal the blue eyes. Well, if we're looking at this, you can either look over here at your information already given. 25 plus 50 is 75 for blue, only 25% for brown eyes. Or you can look at your Punnett square, either way. So this would be 3/4 had the dominant trait, and only one had the totally recessive, which is little. Also, your phenotypes have to equal 100%. If they don't, you did a calculation wrong. All right, so that was the first one that was already given. So let's try to do one that's totally separate. So example 2, we're crossing between a heterozygous red hair, or someone with red hair, and a homozygous blonde hair. Remember, your phenotypes are given below here. They tell you that the red hair is a capital letter. Lowercase, or the recessive trait, is blonde hair. So we're going to use that information when we look at our phenotypes. So let's see if we can kind of figure out how in the world they got phenotypes on the Punnett square. So for a heterozygous, remember hetero means different. So this would be big, little. When I see the word and, I'm going to put an X on it because that separates the two individuals or two different organisms. Homozygous means same. I just got to figure out if it's going to be big, big, or little, little. Blonde hair. Remember, red hair is the dominant. So if it's heterozygous big, little, we're using the letter R. This would be a capital R, lowercase r. Now, for homozygous, I'll look at, well, which trait are we looking at? So blonde hair, that's the recessive. So that's little. We're going to be using a little, little, which would be little r, little r. This one came first, that one on the top. This one came second, so I'm going to put it on the side. However, remember, U doesn't matter. So now, sure enough, that's how they got their genotypes. Now let's match up our Punnett square. You have a little and a big in the first one. We usually write the dominant out front. Top right, you have a little and a little, little, little. Bottom left, you have a big and a little. Bottom right, you have a little and a little. All right, so now we've completed our Punnett square. Now we got to fill out our genotypes and our phenotypes. We always list all of the different phenotypes we can do with the variable given. However, you might not have all of them. So for big, big, none of our squares have this genotype. So this one is going to be 0 out of 4 or 0%. Big, little, you have 2 squares. So that's going to be 2/4, which is 50%. So then you have 2 of the homozygous recessive. So that would be 2/4, which is 50%. You can check, and that equals 100%. So we are good. So for phenotype, if it has a dominant trait, I'm going to color in the dominant one red because that's the hair color. So red is our dominant. Sorry, y'all. So anywhere there is a dominant one, you can look at your percentages. You can do 0 plus 50. I should get 50 here and 50 for blonde. But let's check. So here's one. That one would be red. The dominant is apparent in this part of the square. So this one will be red too. Sure enough, we're left with 50/50. So 50% chance to get red hair and a 50% chance to get blonde hair. So anytime there was a dominant trait of red hair or that red allele, we had to color it in. That's what we get 50%. All right. Let's look at one more example, and then you're going to have some time to work on more on your own. We're going to do a cross between a homozygous yellow pea. Remember, homozygous means same. And we're doing it with a homozygous green pea. Remember, again, homozygous means same. So now we got to figure out if they're big, big, or little, little. Well, looking at your pea, the dominant trait for this one is yellow pea. So if it's homozygous, you're going to have 2 capital Y's for the dominant trait. So this one would be homozygous yellow pea. For homozygous green pea, well, green is the recessive trait. So I would do little, little. Make sure you can tell the difference between your capital letters and your lowercase letters. Because I know sometimes it's a little easier to do with certain letters of the alphabet. And sure enough, this one goes on top because it came first. This one goes on the side. All right, so now we match up our Punnett square. We have big, little. We have big, little. We have big, little. And we have big, little. For genotypes, we always list all the possibilities with our letters. So you do big, 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 little, little, little. Now remember, you don't necessarily have to have all of these genotypes present. So for big, big, none of our squares have that. That would be 0 out of 4, 0%. Then we look for heterozygous, big, little. Well, all of our squares have that. So that would be 4 out of 4, 100%. Always check for every possibility. So for little, little, none of them. So you'd have 0 out of 4, 0%. And that equals 100%. So we're good. Also, guys, remember your phenotype should also equal 100%. I didn't do that earlier, but it does equal 100% on that one. So now let's check for phenotypes on this one. The dominant trait, I'm going to color in mine. It's going to show up kind of more of an orange color. Well, yeah, a little bit more orangey. Sorry, didn't find a yellow. So for yellow, dominant is traits. We're going to color those in. So we have this one is dominant. This one is dominant. This one has a dominant allele. And this one has a dominant allele. So this one is 100% possibility of having a yellow pea. None of them were totally recessive to be green. in order, so this would be 0%, and that does equal 100% when you're adding them up. So first things first, genotypes, you're looking directly at the Punnett square. Phenotypes, whatever the dominant trait is, it has to have that. So it would have to either be big, big, or big, little. Anytime you're looking for the recessive trait, it has to have 2 recessive alleles, or little, little. All right, guys, it's time for you to practice some on the back by yourself. You have 5 problems to do. After you have completed it, check back to part 2 to see how you did.